Today we will be discussing LCM, which stands for lowest common multiple. So a lowest common multiple of two numbers A and B, LCM of A and B, is defined as the smallest positive integer which is a multiple of both A and B. So what do we mean by that? So suppose you are, let's try to understand this with a couple of examples. So suppose you're given numbers 4 and 6 and try to find the LCM of 4 and 6. So one of the easiest method to find out is trying to find out all the multiples of 4 and 6. Okay, so the multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, so on and so forth. Similarly, the multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72, so on and so forth. Now, as you can see, the common numbers between these two series is 12. 12 is one common number because it exists in the multiples of 4 and multiples of 6. Similarly, 24 is the next number. Then 36 is the next number. Then 48 is the next number. Okay, so on and so forth. So the common multiples are 12, 24, 36, and 48. These are the common multiples of 4 and 6 and so on and so forth. Now the least of these common multiples is 12. Okay, and according to the definition, LCM is the smallest positive integer which is a multiple of both A and B, or which is the smallest of the common multiples. So LCM of 4 and 6 is equal to 12. Let's take one more example. To find the common multiples of LCM of 8 and 12. 8 and 12. LCM equal to how much? So we can write the common multiples of 8. 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, 96, so on and so forth. Similarly, the multiples of 12 are 12, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144, so on and so forth. Now, as you can see, the common numbers between these two series, or the common multiples of 8 and 12, are 24 is the first one, and 48 is the next one, 72 is the third one, 96 is the fourth one, so on and so forth. So the common multiples are 12, 24, 48, 72, 96, so on and so forth. Okay, now the least of these common multiples is 24. So LCM, or the least common multiple, is 24 for 8 and 12. Okay, so the least LCM of 8 and 12 is 24. As you can see, this method works very good if you have smaller numbers, and where you can easily write the multiples. But if you have larger numbers, or if you have like more than 2 numbers, or even if you have like 3 or 4 numbers, this method becomes cumbersome to follow through. So let's try to find the LCM in a much more easier way. Given LCM of 4, 7, and 12 is equal to how much? So you're supposed to find out the LCM of 4, 7, and 12. Now in this method, what we do is we try to factor each of these numbers by the prime numbers. Okay. So let's write the numbers in the columns 4, 7, and 12. These are the 3 numbers that are given. So the first prime number is 2. Now let's check if 2 goes into any of these numbers. So 2 evenly divides 4 and 2 evenly divides 12. Evenly divides means that there is no remainder. So if 4 is divided by 2, we have a remainder of 0. So we choose 2 as the number first. So that's the first prime number. Now 2 divides 4. So we get 2. 2 doesn't go into 7. So we just keep 7 as is. Now when you divide 12 by 2, you get 6. Okay. So now again, as you can see, again we have 2 and 6, which are evenly divisible by 2. So let's use 2 again. So you have 2 goes into 2 1 times, 7 let's keep as is, and 2 goes into 6 3 times. Now there are no more numbers which are divisible by 2. So let's start with the next number, which is 3. And as you can see, there is a number 3, so it goes evenly. So let's start 3. Let's keep the 1 as is. 7 doesn't go, 7 doesn't go, is not evenly divisible by 3, and 3 goes into 3 once. So let's write that as 1. Now the next prime number after 3 is 5, but there are no numbers which are divisible by 5. So the next prime number after 5 is 7. So 7, let's keep 1 as is, and 7 goes into 7 one time, and then 1 as is. So as you can see, what we have done is, using prime numbers, we have tried to reduce all of the given numbers 4, 7, and 12 into ones. Now the LCM is just a multiplication of the numbers at the top, or 2 into 2 into 3 into 7, which is 4 into 3 into 7, which is 12 into 7, which is 84. So the LCM of 4, 7, and 12 is 84. Now as you can see, this is a much simpler method. You don't have to write the factors, but you can still find the LCM. So let's use another example to make the concept a little bit more clear. Let's say you want to find the LCM of 5, 6, and 9. 5, 6, 9 LCM. Okay, so let's write the numbers here in vertical: 5, 6, and 9. So let's start with the first number, which is 2. So 6 can be evenly divided by 2. So we can write 2 here, and 5 as is, because 5 is not evenly divisible by 2. 6 when divided by 2 is 3, and then 9 is not evenly divisible by 2. Okay. So next prime number, there are no more numbers which are evenly divisible by 2. So let's start with the next one, which is 3. 5 as is. 3 is divisible by 3, so that's 1. And then 9, that gives 3 as the quotient. And then again, there is one more 3 here, so we'll just use 3. 5 as is, 1 and 1. And then the next prime number is 5. So let's say 5, 1, 1, 1. So we reduced all these numbers into 1, 1, 1. And the LCM is a multiplication of 2 into 3 into 3 into 5, which is 2 into 9 into 5, which is 90. So the LCM of 5, 6, and 9 is 90. Okay, so that's how you find the LCM. Now there are multiple uses of trying to find the LCM, because we can look at the uses of LCM in our next video. Thank you.